Hi and welcome to Fresh Thinking by Snowden Optiro, a podcast where we delve into the technical aspects of mining. My name's Tarrant, Elkington, General Manager. Today we're going to continue on a theme of due diligence in mining projects, and particularly focusing on the metallurgical and processing aspects of due diligence. Joining me for this discussion, I've got Dr. Leon Lorenzen. Leon has more than 40 years of experience in the mining industry across operations, research, and consulting across the globe, in many commodities. So thanks for joining us again.
It's a pleasure. I hope we can share some valuable insights.
Great. So today we're going to continue on a discussion on due diligence. So we're doing due diligence we typically do when somebody's looking to buy into another asset or another company, and usually you're trying to assess whether what a seller is trying to come up with is reasonable, representation of the asset, so that a value can be put to that. And so one of the important aspects of that is around the metallurgical and processing aspects. So Leon, maybe we could start, if we're thinking about buying or somebody trying to buy an operating asset, what are the things that you're thinking about or looking into from a metallurgical processing perspective?
Thanks, Darren. Usually what we do is you start off with the process plant as what was designed. So you have to find a baseline. It's very difficult if you don't have a baseline. So the baseline usually is when there was a detailed design and the plant has been constructed. That's your baseline. After that, there's production. So you can look at production and what happened during production and any changes that's been made since then, so that you can change the baseline to a baseline that you can evaluate. Now, a process plant, to be honest, is like a Formula One motor vehicle, to be honest. It's got a body and a chassis and it's got an engine, and the process plant is the engine. So this engine was designed for a specific car and a specific fuel and the same with that. So you look at what it was designed for, you look how it changed, and then you look at how did it perform during the operations with what it's been designed for. And what you have to look at, two things, is that feed to the plant change through that time, or was it very homogeneous and consistent? And if it did change, how did they adapt, or what was the reaction of the plant itself with regards to recoveries, etc., etc. So that's basically where you start off with. So as soon as you've got the baseline, you can evaluate all those things that happened in the plant while it was in operation till when the stage when you evaluate it.
So if we step through some of the things that you might be looking at, like recoveries, right? Specifically. So is what is being forecast by a seller, will those recoveries continue into the future? So how would you evaluate, something like that?
Yeah. So recoveries, maybe I should join because, in a sense, recoveries is linked to throughput. It's linked to ounces, grades as well. So those three things, you all have to look at it in combination. You just can't look at the recovery.
Sure.
So what you have to look at is a grade. So it's gone on similar to what is predicted, and what they expected. And then the throughput as well, that they really get the amount of material through the plant. So what you will evaluate that. So you look at the recoveries. The recoveries might come up very good, etc. But when you start looking at it, you find that sometimes the ounces drop quite drastically, or the operating costs gone through the roof to achieve those recoveries. So it's not only recovery. So it's a combination of that you achieve the recovery at the operating cost or the cost that you say, that you produce the ounces that you're predicting, and that you get the throughput that you're actually stating. So sometimes you get the recovery and the ounces beautiful, but they actually push that plant to about 150% of the throughput to try to achieve that. And that's warning signs. That tells you, and it's not a warning signs always in processing. It might be a warning sign on the geology or the mining or constraints in different areas. So that's what you have to look at. If all three of those fall within the what you expect, then the biggest thing I found is probably throughput, which becomes an issue. I think that most of from my experience in due diligence, there's an issue with throughput sometimes, and it's usually due to the fact that it might become that people move to a different ore body and a different ore characteristics, harder material, softer, or things like that, or they eat clay pockets, which might cause issues, So then you have to go and dig why it happened. So it's looking at results and find out how these things combine.
So obviously, if you're forecasting into the future of recovery, of throughput, of operating costs that are similar to what they've achieved in the past, that gives you some level of comfort. But as you say, the ore might change into the future. It's not, these ore bodies aren't homogeneous. So we need to dig back into the geology of what's coming through. And do you find that, operating mines typically do much test work for what is coming ahead of them, or?
It varies. It varies very much from place to place. But there is still some mines which have the philosophy that the engine can take anything you feed it. And it's usually the case. I mean, if you put 91 into a Formula One car, you'll get it around the circuit. It's not a problem. It's not going to make the speed or the kilowatts or anything else. The same with, if you feed crap to the plant, you're still going to get some result, but it's not to say it's going to be optimal. So that's sometimes philosophy. But I found that a lot of them do realize that it changes. It's a question of how representative is the test work that they performed on that. You with me? Is it a 3 points which you can draw a few graphs through? You can do anything with 3 points, or is it 20 points or 30 points, or is it 5? How representative, where it comes from. So you need to look at that. But the life of mine is very important. So the life of mine plan going forward helps a lot, because you need to understand where it came from. And how do they classify? So you find sometimes that they state that it's similar to what we've done through, but it's totally a new deposit, totally a new area, totally etc. And there's no test work to confirm that, but the geology say they look the same. And that's your risk with throughput specifically. It might be okay with recoveries, but might not be good with throughput.
Yeah, I think one thing that's becoming more relevant now is people processing stockpiles at the end of their mine lives, and potentially expecting the similar recoveries from low grade ores as to the normal throughput as well.
That's right. Yeah. So yeah, I think the history of a process plant for due diligence important, but for looking forward is as important.
Yeah.
And that gives the buyer the confidence that, okay, I'm taking a risk, but I can deal with the risk, or I'm taking a risk, but there's enough information that it's probably going to be a minor risk in that regard. So it's important that the process, is not done in isolation. It have to do with the mining plan. It have to do with the geology and what's going forward. I've seen some that gone pretty wrong, in the sense because, for example, the predicted life of mine plan has gone from open pit to underground, and you can't mine the same rate. You know that, but it's not been taken into consideration. So when the plant was when the mine was bought by the new owner, they could never for the first 8 months get the throughput because there was not enough material on the ROM pad. So that's a risk. The material was fine, but there's not enough.
Yeah.
So that's your risk. So it'd have to be a combination of those things too.
And so if we move on from like operating mines to new mines, is there a change of emphasis? Like obviously there's some new risks because you don't have the existing plant in place.
I think with a new mine, a new operation or a new mine, the big thing is to look at what is the test work being done. Is a material, like we've spoken in a previous podcast, is it refractory or non-refractory? What is the situation? What is the flow sheet that's been designed by the engineers? Why did they select that flow sheet? And what is the decisions they made to select that flow sheet? So you evaluate the flow sheet. After you evaluate the metallurgy, the flow sheet, if they all fall in place, they're fine. Then you will evaluate with regards to, was it done, from limited samples, enough samples? How was the operating and capital cost being predicted? for building this, because obviously they will have to go and find the money to go and build it still. And is the operating cost within what you would expect it to be? So you'll look at a fatal flaw analysis initially. So it's a fatal flaw analysis. And if you find something which looks like a fatal flaw, you have to dig into that and find out why and what happened. And that is a flags that you put up for the investor to go and have a look, if, and maybe it's easy to fix because you can still go and do a bit of test work or go and do a bit of evaluation. So with a future deposit, I think there's still, in the minerals processing area, there's always areas of improvement which you still can do if you find a fatal flaw, where because you can go and maybe still go and see if it's an issue or not. Maybe not within the time of the due diligence. That's the risk of it.
Yeah, I guess you've got a lot of uncertainty at that time around your capital costs, which you don't have in an operating mine. Also around potentially, I think one really topical thing is around ramp up. And actually getting accurate assumptions around, you might get to the throughput that you say, but how long will it take you, and how will that impact on your payback period? How will that impact on your working capital requirements and things like that
Yeah, I think a good thing, all those together with how well was it done by the engineering house. If they done a good job and they actually stand with their accuracy, is it a class 2, a class 3, a class 1, or a 15%, 10%, and you go and look into it and you find that, you can see they got recent rates, they got recent, etc. There's not a lot of factoring and things like that. Your confidence levels is better for the capital cost. But yeah, you're right. The big risk with a future one is there enough material to start mining? To start processing, and is the material what you expect it to be in the first few months, or have you been very optimistic in your life of your financial modeling? You understand? Okay, I'm going to get everything out in the next 6 weeks, and then we find,
Well, I mean, you use your F1, example, and say, well, you kind of need to run the plant to understand and learn a bit more, and it's hard to predict how long it will take to get to that optimal steady state point, right?
But some of them can be very quick, and some of them can take a long time.
And obviously that's dependent on the complexity of the ore body and probably the complexity of the processing methodology that you've
or the type of equipment they bought.
Yeah, absolutely. So and I guess how important is it when you are evaluating a new asset to have somebody that has seen the risks and understands the risks to look over things? I mean, it's easy to take everything on face value, but how important is expertise and judgment of?
I think it's very important, because just like if you buy something, you want to have some comfort that that's correct, and you probably need the comfort of understanding that the person who's doing it, or people, or group of people, or the team, is knowledgeable in that area and done that before and understand that. And I think that's important. I also believe that usually people who do that should also, when you build a new plant, you get a lot of the financing houses that actually have an independent engineer looking at what do you do, or engineers. And you need that experience as well, because you actually, by doing that, you understand what's going to happen during construction and what's the risks in that part of it as well. So you can give that guidance. But again, go and find the right people and and if there's flags and you need more expertise, you get that expertise and find it and find what's the right answer.
Great. And I think, one of the gaps between, maybe a good investment and a not so good investment is actually doing that due diligence when you've got to make a huge investment at some particular time. So it's important to get it right. And I guess, with us at Snowden Optiro, we provide that service quite routinely. It's quite an interesting aspect of our work. But thank you very much, Leon, for sharing some of your insights into this area. It's it's really great to hear what's some of those deeper technical aspects.
It's been a pleasure.
Great.
Thanks.
And so thank you very much for listening to us this episode of Fresh Thinking by Snowden Optiro. If you enjoyed the podcast, please subscribe to our YouTube or Spotify channels, and please tune in for future podcasts where we delve into more technical aspects of the mining industry.